This is 2001 AMC 10, problem 12. Suppose that n is the product of three consecutive integers and that n is divisible by 7. Which of the following is not necessarily a divisor of n? So we have A, B, C, D, E, 5 options here. And let's just test them all out. So n is a product of three consecutive integers. So let's just say that the first integer was a. So we know that n is equal to a times a plus 1 times a plus 2. So let's just try the first option. Wait, and we know that n is divisible by 7. So is n divisible by 6? No matter what a is, no matter what n is n divisible by 6? Yes. Why? Because out of the three integers, one integer, at least one, maybe even two, has to be even. So this means that n has a factor of 2 in it. And out of these three integers that are consecutive, one integer must be the divisor of 3. For example, if you take any set of three integers, 3, 4, 5, 1, 2, 3, 10, 11, 12, 101, 102, 103, one integer in all of these sets will be divisible by 3. So if a number is divisible by both 2 and 3, then it's obviously divisible by 6. So yes, 6 is a necessary divisor of n. So n is divisible by 2 and 3. Okay, so what about 14? Well, yes, 14 is not the right answer. But yes, 14 is obviously a divisor of n at all times, because we know that n is a divisor of 7. Sorry, n is divisible by 7 and n is divisible by 2. Right? And we also know that n is divisible by 3. If n is divisible by both 7 and 2, 7 times 2 is 14. If n is divisible by both 7 and 2, it's divisible by 14. So B is not the answer. What about C? It's kind of clear over here because n is divisible by both 3 and 7, and 3 times 7 is 21. So n is also divisible by 21. What's about 28? Well, there's no proof here that n is divisible by 4, is it? Though, let's just try this out. A bit of casework here. One case is that if a is divisible by 2 and a plus 2 is divisible by 2, one of these two numbers has to be divisible by 4. In that case, if there are two even numbers in this consecutive product thing, then n is divisible by 4. But in another case, such as a plus 1 is equal to, so if a plus 1 was the even number, a plus 1 might not necessarily be divisible by 4. Well, is this case actually possible though? Well, one example of this where n is also divisible by 7 is 5, 6, 7. We know that a plus 1 is equal to 6. And 6 is an even number. It's an even number in the sequence. But 6 is not divisible by 4. But 6 is not divisible by 4, yeah. And n is still divisible by 7. So this exists. So if it's this case, then n is not divisible by 4. So this case does not stand. So if n might not be divisible by 4, it might not be divisible by 7. So it might not be so if n might not be divisible by 4, it might not be divisible by 28 because 28 is divisible by 4. So D is the answer. But let's just check E. Well, 42 is made up of 6 and 7. We know that n is divisible by 6 since 2 and 3 are factors of n, and 7 is also a factor of n, so 42 is a factor of n. So E is not the answer, so the answer is D.